I was a technical writer for 20 years, so during the entirety of Chastity's talk, I was just sitting there going, or you could hire a technical writer. Like, it turns out we have experts in how to do this, and they're lots faster than your engineers. So, like, alternate theory, hire a technical writer. All right, who's ready to talk about disasters? Yeah, I love disasters. I don't know if you do this on the Autobahn, but in America, we always slow down to look at car accidents because we're curious and we want to know what's happening. And then there's like this tiny fender bender and a giant long backup because we just cannot resist the impulse to look at other people's disasters. And we love disasters because they didn't happen to us, and we want to know how to avoid them happening to us. So this is a story about Y2K and a bunch of other exciting things. Let's see if I get to have Bluetooth. It was working 10 minutes ago. It was working 3 minutes ago. It doesn't like me. And I can't put it up on the presentation thing because network incompatibilities. So I'm just going to wave at the poor nice man who's going to have to advance for me. Sorry. There's only 45 slides. It could be worse. So what I'm here to talk to you about is Y2K. How many of you were working in the industry during Y2K? Ah, the few, the grizzled, the proud. I, too, was working in IT in Y2K. Thank you. And this is a story about my friend who was a systems administrator, and she was from Des Moines, Iowa, which is the middle of nowhere. There's a lot of cows. I don't know that Europeans can comprehend how far apart the middle of our nowhere is, but she was going to go from her middle of nowhere to Minneapolis, the big city. It was about a 4-hour drive, and it was December 31st, 1999. And she had made a bet with her boss, and the stakes of the bet were her job. Her boss said, if anything goes down while you were in Minneapolis being frivolous, you 23-year-old, don't bother coming back. You don't have a job. It's not a thing. Aha, it worked. So this is an actual pager. This was what we had before cell phones, and what happened was you clipped it in on your belt, and you kept checking it compulsively because you would get like this phantom buzz, and it stayed on your belt till you dropped it in the toilet because it wasn't well attached. And when it went off, assuming you hadn't dropped it in the toilet, what would happen is you would have to go find a payphone and call into work. And you'd go to a dance club, and you'd see somebody who was like standing at the dance club like this with their finger in the air, talking into a payphone, saying things like, yeah, well, what did it do? What's the error message? Oh, never mind. I'm just coming in. Because in 1999, remote administration was not really a thing. Like, we had to go and fix computers with our actual fingers. Who here is getting a chill remembering that? And it's sort of like a memory chill because server rooms are frickin' cold. And if any of you have ever made a woman pump in a server room, I'm judging you. Just saying, my sister had to do that. Actual server room. So, let's talk about Y2K. We were really worried. We were really genuinely worried. Those of us who were working in the industry do remember that. Those of you who were, I don't know, born after that may not. But it was pretty scary because we didn't know what was going to happen. We thought that it might be the end of the world. This is not like a mock-up. This is an actual Time magazine cover. And like the whole last half of 1999 was filled with alarmist news stories like this. And you're just like, I don't know, but if the world ends, at least I won't have to read one more story about how the world's going to end. We knew that we had a problem. We knew the problem was coming, and we started preparing for it a few years out. Not as many as we should have, but enough. And one of the things that we had to do was get into all of the mainframes that were and still are running enterprise businesses and fix the dates. Like every time you use a healthcare website or airline booking or something, you think, okay, this is pretty modern web interface. I assure you that there's like 14 layers of abstraction and like an OS 390 system in the basement. And I can find all the sysadmins in the crowd. And it's just like this whole teetering pile of abstractions based on a database, or based on a mainframe system that you can't take out because nobody knows exactly what to do. And when we were doing this, there was a thing that we were proud of how long our computers could stay up. We were proud of how long our servers would stay up. We're like, yeah, I got 4 years of uptime on this baby. It's never been rebooted. It's the best thing ever. I'm so good. The problem with that is when you reboot it, it's a much more chancy affair. There's every possibility that it's not going to come up. So not only did we have to redo all the software on these, we had to reboot them to make the software take effect. And sometimes they didn't come back up because hardware turns out to have a life expectancy. And if you keep running, it's one thing, but if you start, it's a whole different problem. A lot of people talk about how exciting the space program was and how there were these thousands and hundreds of thousands of people hours that we committed to it and how exciting it was that we all pulled together and did this. I tell you what, that was penny ante compared to what we had to do to fix Y2K. Nobody working in the industry during that period escaped unscathed. We all have little trauma, little scar about this. And that's not even counting all the people who are retired now who worked on it. So we look at the space program and we're like, yes, we accomplished a major thing. We all worked together. It was great. We don't do that for Y2K because nobody remembers that you averted a crisis. Nobody's like, yes, today I drove to work and I didn't get in an accident, and all of my computers stayed up, and I drove home and I didn't get in an accident, and also I cooked dinner and nothing caught on fire. It's not really how we run our day, and it's based on a whole bunch of human cognitive biases about the expected and the unexpected. But it means that even though we have worked our asses off for 3 years, we're not going to get credit for averting Y2K because life went on as normal. There were some outages. They happened in July because people were testing their systems. There were some minor disruptions, but there weren't cascade failures because we'd put in blocks so that we couldn't have cascade failures. One of the problems of interconnected systems is that they can interconnectedly take each other down really fast, right? So how do we do this? How do we get around having disasters and emergencies? Well, the first thing is risk reduction. Risk reduction is trying to prevent bad things from happening. So we use things like vaccination and anti-lock brakes so that when you're on a slippery, icy road and you hit the brakes, they actually stop you, or at least they don't make the problem worse. And we use train gates to stop people from driving across the train tracks because it turns out you never win. I mean, frequently you win, but if you are wrong, you are really wrong. So when we say risk reduction, what we mean is don't make it possible for the bad thing to happen. Block that opportunity. So how do you reduce risk? First, you have to figure out what your zone is. I took the train from Amsterdam yesterday, and I was just fascinated as an American by the miles and miles and miles of separated bike path. It's not a thing we get a lot of. Minneapolis is pretty good. We have probably 1/10 as much bike path as we have road. It's astonishing. Yeah, but not all of it's separated. And certainly not all of it's off the road. So one of the things that I do as a cyclist in the United States is accept that because I ride in a city and commute in the winter when it's hard to stop and when it's dark and there's snow, I accept I may be one of the people who dies this winter. And I carry a lot of life insurance, and don't kill me. And I have a ID badge that makes it easier to find and identify my family if something happens. And I internalize and accept that risk. So that's my zone. I'm I have not wrapped myself in metal, and that's my understanding of the world. One of the things that I do at work sometimes is directly work on the API documentation, which is auto-generated, like pretty much everybody's API documentation at this point. If you're not using OpenAPI, I'm not sure why not. But I'm not a coder. So there's this exciting moment when, in the process of working right in the API documentation, I'm also working right in the API. And if I screw something up, I could actually break things for customers. So instead of letting me just randomly commit shit to the customer-facing API, somebody reviews my code. Somebody says, yeah, no, that's, you just removed an entire call, and that's not okay. I'm like, so we have these checks and balances as part of our everyday working life because we understand that humans are pretty much not only fallible, but constantly just tripping over our feet in forward momentum. And so when we work together, we try and mitigate that risk. The last thing is state machines and state charts. And I am the English major most likely to draw a little heart emoji around a state machine because I think it's such a useful way to think about everything we do, to think about uptime, to think about security. What is the state of something now? What are its possible future states? How did we get there? It seems really elementary. You're like, how much design are you really going to do with the flowchart program? A lot. You're going to do a lot of design with the flowchart program. And it doesn't even have to be your actual architecture. It just needs to be an understanding of the state your system can end up in, right? What does it look like when your system fails? 99 point whatever, how many nines you feel like paying for, you don't need the state machine. That tiny edge percentile, that's where you need to know how things can go wrong. So when we're talking about risk, you have to accept that you cannot prevent everything. Everything is a trade-off, and you just have to accept which risk is least horrible for you. Decide what matters to save. I think it's really interesting. I was working on the BitLocker project at Microsoft at the very start of it, and we had this stunning realization that hardware means nothing. Laptops were expensive, but they weren't nearly as expensive as an access breach. They weren't nearly as expensive as people getting access to the data that's on the laptop. We would rather the laptop went up in flames than anybody actually get into our network. And that was like this revolutionary shift in thinking because for so long, the way we had handled data and the way we had handled hardware were different. And we're like, oh, well, sometimes you lose things and you have to restore from tape, but save the machine. And now that we have this easy distributed software access and data access, we're like, burn the machine, save the data. I would like to note that BitLocker does not actually set your disk on fire, but full disk encryption will, in fact, lock you out if you don't have the stuff that you need to get to it. Like, it's gone. It's a great way to secure your drive before you donate your computer. And you need to make mindful trade-offs based on data. You all know this statistic, but it is more dangerous to drive to the airport than to take the plane. Air travel is super safe. Car travel is not super safe. But because of the differences in how often we do one or the other, our lizard brains have to believe that driving is perfectly safe or reasonably safe. That doesn't work when you're at work. If you're going to make a trade-off, make it based on data and not your gut feeling. All right, so we would like to avoid bad things happening, but they're going to happen. Bad things are going to happen. I teach junior high sex ed. And one of the things that's like an essential core tenet is we would like it if junior high students were not having sex. I don't think that's like super controversial. But we know they will. And therefore, we have to teach them how to be safe about it. Even if we don't want them to do it, Denying them knowledge just means that when there's a failure, it's more catastrophic. Harm mitigation is all about making failures less catastrophic. Because things do go wrong. Our anti-lock brakes don't always work, and sometimes we hit it and we need our seatbelts. We want to not go through the windshield just because we hit a deer. Is that a thing that happens here? I grew up in the country. So this is Mexico City. The picture on your left is what is left of a hospital after the 1985 quake, which was 8.2, I believe. There's not, as you note, a lot left of the hospital. It was pretty bad. And a lot of people died, about 10,000. We'll never know the exact number, because that's how it is in mass casualty scenarios. The picture on your right is the 7.9 earthquake that happened last year, and that is the worst damage picture I could find. What is the difference between those? Building codes. Building codes save lives. If right now a fire alarm went off, the first thing that would happen is you would all head for the exits, which are clearly marked with green signs with a little running person, which I think is great and even better than saying exit. And you would hit a crash bar. All the doors in this conference center open out because we have residual cultural trauma that comes from pictures of people piled up in front of egress doors that open in. In a mass panic situation, people don't slow down enough to open a door in because there are bodies pressing behind them. People die from door design. And the way you make people do good doors is not say, hey, you should do good doors. You should make all of your exits actually open out. You make it a rule, and then you fine the heck out of people who don't follow it. Because otherwise, there's no incentive to do the right thing. Like, doing the right thing, if it costs 2 pennies more, it's not going to happen. It's a problem with humanity, but it's true. So building codes. Here's 2 more compare and contrast pictures. That is Grenfell Tower. We think the casualty is about 82 people died in this. What happened is, to make it a more beautiful aesthetic building, they put up some cladding on the outside so that it looked less 70s brutalist and a little more sleek and modern. But the building codes didn't mandate that you checked how that was going to work on the building. Like, the cladding itself was relatively fireproof, and the building itself was relatively fireproof. But the combination was catastrophic because it created a chimney that sucked all of the fire up and into the windows of the formerly fireproof concrete blocks construction. And then, bonus points, and nobody tested for this, it outgassed cyanide. So what's happening is this formerly relatively fireproof building where people had been instructed to shelter in place because the fire didn't leap from room to room, was suddenly, the whole concept was violated. And even that wouldn't have been catastrophic if they'd had enough fire exits. But because the UK didn't have the same kind of cultural trauma that America did, they have one central fire stair, and it was at least partially blocked. There were like old fridges in it. Because where are you going to put that stuff? Like, if your landlord doesn't take it away. And if your fire inspector doesn't force your landlord to keep your one stairway clear, you're kind of screwed. This building, this building is the unfortunately named Torch Tower in Dubai. It is twice as high as Grenfell Tower and has almost exactly the same cladding on it. And when it caught fire, you could tell that it really caught fire. Like, it went up the cladding the same way, right? Nobody died in Dubai. Nobody died in Dubai. Do you know why? There were 4 exit stairs. There were exit stairs in each corner and the center. And so when the fire started, the fire alarms actually went off, making it better than Grenfell, and people could evacuate. The reason you don't see this kind of picture much from like Chicago is because they have draconian sprinkler standards. A high-rise building like this in Chicago will have a sprinkler in it, and there's a 2% risk of floor-to-floor spread of fire in a high-rise with sprinklers. 2%. Like, that seems like a pretty good deal. The reason landlords don't install it is because sometimes they go off by accident. Somebody, you know all those signs in hotels that say, please do not hang your clothes on the sprinkler head? Those signs exist for a regrettable reason, and that is sometimes the sprinkler heads get knocked off and the system dumps, and you have a false positive, and people's stuff gets ruined. And nobody likes that. It's really expensive for the landlord. But nobody dies. So when we're thinking about mitigating harm, we don't have to think about just like the likely things that are going to go wrong, although you should start there because, like, let's pick the low-hanging fruit. You also have to think about the unlikely things and how much you're willing to pay to prevent them. When you think about this, you want to think about whether you're going to fail safe or fail secure. So fail safe is what happens in nuclear power plants. And if there is a loss of positive control for even a second, the control rods slam down, and the reaction starts. Fukushima, there's a whole bunch of things that had to go wrong in order for that to happen. But basically, you're not going to get a runaway reaction because we've engineered to destroy the power plant rather than leak, like at the extreme case. The other example I like for this is there's a device called a saw stop. Anybody here used a circular saw in like shop class? Yeah. Saw stop has a weird detector that can sense the piezoelectric conduction of your thumb as opposed to a piece of wood, and it slams the brakes on. And literally, like they demonstrate it with a hot dog, and it's hypnotic because like the hot dog gets this tiny little scratch on its casing, and the saw blade is destroyed. It's about $300 to replace that unit. But you know, $300 seems like a lot less than losing your thumb. So what we've done is designed a fail-safe to protect your thumb that will destroy the machine. So when you think about what your risk is, you need to think about like the human cost of risk. How many of you worked in buildings with Halon data centers? Right. How many of you felt happy about that? Nobody. It turns out that they're pretty safe as long as you go ahead and have the masks in the data center room. For those of you who don't know, halon is a heavier than air gas that will put out a fire really darn fast. Also not super healthy for humans in the part where they don't have any air in their lungs and they die. Because turns out fires and humans need a lot of the same things. So it was a calculated risk to put in halon fire suppression systems. We said, this data center is worth risking a human life for. Whether that is a correct estimation or not, that was the calculation. And we did some mitigation to try and make sure you wouldn't die, but it was the trade-off. That was the deal. When you're thinking about doing this, you need to assume failure. And the problem is, you can't figure out where you're going to fail, or you wouldn't fail there because you would have already mitigated for it. But failure is almost always an oversight. And one of the things you can do to keep from having these oversights is to test with more than one kind of person. And if you're not doing failure testing with more than one kind of person, if you're assuming everybody who's invoking failures is the same as you, you're going to have a really inaccurate picture of what goes wrong. Like, there are 1,000 things that an adult human wouldn't do that a toddler would. The greatest part of parenting is the number of unique phrases you get to utter. Things that have never been said in the history of time. My personal favorite was, please stop scraping the ceiling texture off the ceiling with your sister's doll's face. Like, nobody has ever had to say that before, but parenting is the act of raising people who think that's just a weird thing to have to tell somebody. Like, why would you do that? You need to find testers who make you think, why would you do that? And then you need to hire them and pay them good money because they think in a way that we don't. And it's important to have somebody do that if you care about a resilient system. Then you have to accept that even though you've done what you can to prevent failure and predict it, you're not going to prevent them all. So you're going to have to make failures less catastrophic. You're going to have to stop the runaway chain reaction. Failure is inevitable. Failure is inevitable. You are going to fail. You have failed at something today. You will fail at something tomorrow. I failed to check what kind of plug on my iPad for this video, but you know what? It wasn't a disaster. We worked around it. So what's a disaster? Disasters are complicated and hard to explain. We know them when we see them. We've all experienced watching the postmortem on a disaster as opposed to a failure, but it's hard to define what causes them. Because they're caused by a number of different things. It's not that a failure has a source. There's no root cause for failure. There is instead a multiplicity of aggravating effects. And you can't test for them all, because this is just 2 planets in orbit, and it's a relatively regular orbit. Now imagine you're 100 microservices. You can't test all of those paths. So what are you going to do? You're going to have to figure out some way to test the most likely failures and some way to make it so that when it fails, it's not the worst thing ever. The best, fastest way I know of to do this is to have a kill switch. If you have a way to turn something off, then it can't keep spitting out wrong data. It can't keep being wrong. Sometimes its absence is a different kind of failure, but probably one that you can predict. If one of your 100 microservices goes down, you probably have a plan for that. You're like, oh, let's restart that. Because I really believe that technology is the emotional equivalent of a cranky toddler, and sometimes it just needs a nap. There's no reason that restarting it should make it work again. And you can have all of the theories that you want about resetting the system registry and whatever. No, it just needed a nap. It was just throwing a hissy. So if you turn it off and on again and it works, probably you don't have a problem. If it keeps going down, you have a problem. But once in a while, it just gets cranky. So give yourself a way to turn things off in small sections instead of a giant everything goes off button. Because if you only have the one everything goes off button, you wait too long to hit it and things get worse, right? Because it's going to be a disastrous recovery. Or you don't hit it when you should because you think it's going to restore itself. But you have this calculation, oh, that's a very large choice. If you have a tiny choice, if you're service 42 is giving me trouble, you pop it off and on again, it's not a big deal. So think about adding more kill switches to all of your instrumentation, all of your services. Give yourself a way to make micro changes that prevent cascade failures. Because what you want to do is walk away from a failure like a cat falling off the bed. I have a super suave cat, and when he falls off the bed, he's just like, yeah, I totally meant to do that. I'm practicing my aerobics or something. So what's a disaster? This is the 35W bridge in Minneapolis, where I live. Only that's not the 35W bridge anymore, because this bridge, on a beautiful spring day, fell into the river. A lot. Very hard. Very suddenly. Surprising everyone on it. 13 people died, and it could have been so much worse because it was mostly closed for construction. And we were all like, I don't feel happy about bridges right now. I do live in a city that has 14 rivers and a few thousand lakes, but I don't like bridges because they fall down randomly. So the thing that happens is the National Transportation Safety Board and the Army Corps of Engineers comes along, and they dig out the bridge, and they pull it out of the water. And they're like, okay, what happened? They make these great charts. It's a very long report. I didn't read it all, I will confess. The first 500 pages were enough. What happened was The gusset plates, that's these wacky rivety things. The gusset plates that join the two steel beams together were half the thickness that had been specified in the original design. Well, that's no good. But this bridge was 60 years old. Like, it had been up for a long time, and the gusset plates had not previously crumpled. So what else was going on? Well, we had resurfaced it and added a 200 or 300 ton additional concrete pad, not to mention the weight of the de-icing system, not to mention the fact that they were resurfacing one side of it, so there were, 2 extra roads worth of material on the bridge so that we could strip off 1 bridge worth and replace 1 bridge worth. And there was a lot of construction equipment, and there was a lot of vibration. And it's not that the accident was caused by vibration, or excessive weight, or gusset plates, or mild corrosion. It's that all of those things combined caused the bridge to fail suddenly and catastrophically. You have all had that day. You have all had that day where, one of your shards is a little bit flaky, but it's no big deal, until, one of your routing algorithms is a little bit weird, and it puts a bunch of traffic on the slightly flaky cluster, and then the cluster falls over, and then you didn't have quite enough excess capacity, and then the second cluster falls over, and now you're really humped, and you're like, how do I even stop this? Beep, 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 beep. Disasters are something that we can prevent because we can do things to stop the consequences of failure. We can stop disasters by stopping the chain reaction. So we have to admire Netflix for designing for that. We have to admire Gremlin for actually making Simian Army a useful concept, because let's just go randomly break shit while it sounds really fun is not actually a super great business prospect to try and pitch to your boss. But if you hire consultants, it's for real. That's how it works. If you take some essential part of your infrastructure offline and anyone notices it, that's a failure of your test. If you can take an essential part of infrastructure offline and your users never notice, you have succeeded. Go team. So one of the things that we do is make sure that our infrastructure is not so tightly coupled that it falls over immediately when we have a problem. So I'm going to go into this a little bit more, but what are the fizzle factors? This is your take a picture slide. What are the fizzle factors that cause failures not to cascade into disasters? Microservices and loose coupling, fault-tolerant messaging, data duplication, Canary launches, kill switches, circuit breakers, and release valves, automatic recovery, testing for load, stress, and outage. All right. Microservices and loose coupling. I don't have to go into this a lot for you like I do sometimes for the deep code people, but let's just say that if you have a whole bunch of interdependent microservices, you don't have microservices. You have a distributed monolith. And a lot of us work in a distributed monolith environment that we lie about. But the less we could do that, the more resilient everything was going to be. So I want it to be, if some ingestion goes offline, there's caching for that so that you don't lose everything. You don't want to lose people's shopping carts. That's really bad. Fault-tolerant messaging. Who here remembers when S3 went down? Right? Who here remembers why they didn't know why S3 went down? Yeah. It turns out the icon that indicated S3 had an error state was stored on S3. That is the classic example of fault-intolerant messaging. Do not put your status page on your own site. We have people who do that. And I don't actually just mean complaining on Twitter. There's status page IO. So think about how you're going to do messaging so that you and your users can find out something is down without needing the thing that's down. Data duplication. I have a whole talk on throwing data away, and this one isn't it. Data storage is cheap and fast and reliable. Please duplicate your data to at least some degree for some part of your day so that if you lose something, you haven't lost everything. Because it's really easy to spin up your secondary cluster. And the example I use for this is Delta. I'm a happy Delta customer. I flew Delta here. It's the least horrible of the American Airlines. It's not actually saying a lot, but we get what we get. They merged with Northwest Airlines, and they had 2 data centers, one in Atlanta, where Delta is based, and one in Minneapolis, where Northwest is based. And they closed the Northwest data center because who needs 2 data centers, right? Right up until the one in Atlanta literally caught on fire. It's really difficult to recover from my data center has flames spurting out the sides. Like, that's just a problem. If they had had their duplicate data center up in Minneapolis, they could have failed over really fast. I hope they think of that all the time, because I'm super bitter about that. But if they had had some kind of redundancy, they would not have lost like 3 days of miserable traffic and vouchers and like 2 weeks of knock-on effects. So if you can at all afford to duplicate your data and your state, please do that. Canary launches. I work for a company that does feature flagging as a service, and so I talk about this a lot. And what we're saying is, when you deploy something, it's not the same as releasing it. Like, that's the first thing you have to understand. Putting the code out in the world is not the same as showing it to the world. So when you deploy something and you want to test it with 1%. Test it with 10%. Whatever makes sense. I know companies that do all of their testing in New Zealand because they're English speaking, and according to companies who live in San Francisco, they're in tomorrow. So if something is going to go wrong tomorrow, it's already happened in New Zealand. It's very effective. And it's a relatively small market. There's only so angry they can get. Sorry, New Zealand. So when you're doing a launch, consider doing it with just a percentage instead of doing a smash all on for everybody all the time. Kill switches and circuit breakers and release valves. These are all automated ways to stop a cascade failure because the slow, unresponsive part of any system is us. Meat is very slow to react to internet time. So if you have a whole bunch of things that, like, if it goes above this threshold, start throttling it. That's like a pressure release, right? And if you have something that's like spitting out a bunch of garbage data, just go ahead and kill it. And if you have something that is causing repeated failures, maybe there should be a circuit breaker. Think about how you could use turning things off as a way to keep control of the whole system. Automatic recovery. Like I said, sometimes things just need a nap. If something comes up, or if something goes down and you're going to precisely run a runbook series to get it started up, please stop doing that and just script it. Like, if it's a thing that you're not going to deviate from, script it. The second time it goes down, go ahead and page somebody. Test for load, stress, and outage. Because you don't want to be testing on a normal Tuesday. You want to test your system against Black Friday when you have a sale. And you want to figure out how you can gracefully degrade what you're presenting so that people can still buy their Black Friday gagas. So when you're thinking about it, think about testing for actual catastrophic load and not normal load. So if this was too long and you read Twitter, here's the summary. Expect failure, make your systems less rigid, plan for disaster because it will happen, and degrade gracefully. I was sent here by LaunchDarkly. If you want a t-shirt, I do not travel with t-shirts because I'm a princess. If you want a t-shirt, take a picture of this URL and go visit it, and we will send it to you, which is pretty exciting. And we are hiring, but like Corey and John said this morning, we are hiring only in Oakland, which is like San Francisco, but cheaper and with way better dumplings. So if you're interested, in working for LaunchDarkly, we have an SRE position open and a bunch of other stuff. Thank you all.